This is me. During business hours, I wear a suit. After hours, I focus on my family, my struggling golf game, my unhealthy affinity for whiskey, skis, not snowboards, charcuterie and some artisanal cheeses is always good. And then I'm like I just said, I'm a Chicago boy. So Bulls, Bears, don't hate me for it, please. Founded Cohesive FT back in 2006. I represent myself as either the marketing director or the products director, depending on the audience that I'm speaking to at any one time, whatever serves me the best. Self-promotion is important. Twitter handle's up there. I don't say much, and it's not that interesting, so don't worry about it. What we're going to do, just give you some background on how you might want to weight my opinions on cloud today, give you a little background to where we come from, how we see the market. Talk about who's actually the players. Moore's Law, my marketing team put that in there. I don't know if it's such a law anymore, but whatever. Talk about the costs of cloud, as opposed to physical, as opposed to a couple years ago in the cloud and that kind of stuff. And then we'll talk about what it takes to go for traditional WAN versus cloud WAN. And then we actually have some people doing this today, so I just want to talk about some use cases. And I'll try to keep the product pitch to a minimum. If it starts getting too much, raise your hand, and I'll take a pause, try to de-marketing a little bit, and get back to the general value prop. But I do want to talk about what people are actually doing, and then talk a little bit about my next gig whenever I drive Cohesive into the ground or I sell it. So the cloud market, where do we fit? Been a company since 2006. We thought, virtualization, open standards, open source. There's going to be some transformative convergence there that was going to impact the data center. We wanted to get in on it, and then people started calling it cloud. So we started playing the cloud game. We've done 80 million virtual device hours. We're in Chicago, London, Palo Alto, and then Belo Horizonte down in Brazil. What we do is, when we say cloud, I'm talking about infrastructure as a service. That's what we're going to be talking about today. We'll give a little overview about SaaS and PaaS, and that's great. Feel free to use it, and a lot of enterprises do, and that's good. But we're going to talk about infrastructure as a service. And what we do cloud networks and automation. Cloud networks, you'll see buzzword SDN up there. I don't know if anybody brought their buzzword bingo card. We'll get to that later. But on the automation front in the cloud, we talk a little bit about image management. How do I get my servers to the cloud? Partners, organizations, and awards, there on the bottom. So cloud's mainstream. Even your mom knows about it. It's been in The Economist. So stuff reaches The Economist. You're 3 years too late. But the good thing is prices keep going down, so there's some money to be made there if you leverage it in the appropriate way. We're talking about IT as competitive advantage, not just IT as a cost mechanism. SaaS at the top, software as a service. You'll probably recognize some of those logos. Google Apps. Anybody do a Hangout recently? That's a software as a service. Salesforce is customer relationship management as a service. Same with SAP. There's a bunch of kind of big data analytics built off of Hadoop. We offer our networking solution as a software as a service. Dropbox for file sharing and backup. Infor for like BPM. And then Hootsuite, because Twitter is great. PaaS, Force.com is a subsidiary of Salesforce. And what PaaS is just everything from the compute up through the OS, and then providing you with some virtual container to plug your app into. And then it's highly scalable, it's really flexible, and it works great on these platforms as a service. So Force.com, Heroku, they bought Heroku. You can write stuff in Java, PHP, a bunch of different languages. All of these guys essentially hit the same ones, like Ruby on Rails, PHP, Java. So that's Force.com and Heroku. Google App Engine is the engine. OpenShift is Red Hat's platform as a service offering. Engine Yard was guys that started with Ruby on Rails and started adding on different frameworks and languages that you could build your apps with. And then Amazon Web Services. they have Elastic Beanstalk, which is a competitor to these guys. Now, down at the bottom is what we're going to be talking about today, and that's infrastructure as a service. And at the baseline, infrastructure as a service is commoditized access to virtual compute, virtual storage, and underlying network capacity. So they allow you to launch a virtual machine in their cloud, and then you can run it, and you can run whatever you want on top. And the players in that, I don't know if you guys have paid attention to Gartner. They're an analyst out there. They, do independent analysts exist? Who knows? But they do their magic quadrant, right? So there's like the leaders quadrant, and it usually is some distribution kind of from the lower right, lower left to the top right. Amazon's all the way up in the right, and then everybody's down near the middle. Is the lead that great? It's unclear, to me at least, but it seems like the current leader is Amazon, just from current install base, the user base, and definitely the number of services that they've added on to those commoditized access to virtual compute, virtual storage, underlying network. But Google, big company, coming up. OpenStack is kind of the consortium response to Amazon's market leadership. So a bunch of companies came in and said, we're going to build the open source cloud, and that's OpenStack. HP is building their cloud off of OpenStack. They actually have OpenStack Grizzly coming out soon, which is going to, I think, make them a major competitor to Amazon. Rackspace also uses a little OpenStack. And then, of course, Windows has a cloud, too, that they not so recently allowed Linux workloads to be launched in their cloud other than Windows workloads.
I think Grizzly's out. I think it's that as the new one.
Is it? So yeah, I know that it's out, but HP has their Grizzly implementation in beta. So when they flip that out to all their regions, that's going to be an interesting way to see how it stacks up to the Amazon VPC offering that is now the default offering, I guess. All right, so I mentioned buzzword bingo. Excuse it for a minute, but I think it's good to just mention some of these things before we jump into it. We're going to talk a lot about the networking, cloud networking. So we've always talked about it as overlay networking, and we've been talking about overlay networks for 5 years. But what it is when we say overlay network, I guess what we really mean is NFV, or network function virtualization. And this is something that's coming out in the cloud. Networking is kind of the new hotness everyone's talking about, and it's the nice new acronym. And what it is it's network functions independent from the hardware. So it's isolation between that virtual network and the physical network. So we always say overlay networks because you're building a virtual network on top of a hardware network. And there's of course, the virtualization functionality means that you kind of have built-in APIs, so programmatic control over your virtual network. Now, the software-defined networking, that's a big buzzword as well because of the multiple billion-dollar acquisition of Nicira by VMware a couple years ago. So that really set off the kind of SDN washing. VMware came out and spent a crap load of money on a company that didn't have any customers and was a bunch of academics from Stanford, and everybody wanted to get a piece of that pie. So you've seen a lot of SDN stuff. And the key here is SDN is all about networks that can be configured through an API. And the distinction is this is physical networks that can be configured through an API. And it's all about the separation between what they call the control plane and the forwarding plane. And it expresses a difference in what's managing the network versus how those packets move around the network. And I'll speak a little bit more about how software-defined networking is being used in the cloud and how NFV is being used in the cloud on this slide. When you're talking about a cloud stack, you can think of it as there's hardware, then there's some virtualization technology, and then there are the things that the actual users run on top of that virtualization layer. So we call it the application layer. Some people call it like the cloud tenant layer or the user layer. But it's whoever's consuming the cloud, that's where you're operating. You're launching your servers up in the application layer. And the cloud provider is providing access to that virtual compute, virtual storage, and underlying networking through the hardware layer and virtual layer. And there is a very specific line that we call the limit of access, user control, and visibility. And it means below that line, it's everything that the provider controls, and above that line, it's everything that the user controls. And generally, the provider doesn't care what you're running. As long as you're operating within the T&Cs, you're not running some botnet or you're not doing some malicious activities, they don't care what you're doing. They don't care generally what you're running. Maybe they have agreements with Red Hat and they're going to collect some license fees from you and that kind of stuff, but outside of that, they don't care. And you as the user, you don't care how they're offering you up that fast, fat, and flattened network. You don't care how they're offering up that virtual compute unit or that gigabyte of storage, wherever it may be. It's as long as it's available, it doesn't matter. And that has some profound implications on how you go about using the cloud. So we talk about cloud owner control, application owner control. And so back to the slide about SDN. Infrastructure SDN is helping that cloud provider offer up that fast, fat, and flat network. Now, at some point, there might be some open flow controls that are offered up through the user layer and allow you to control some of the flow of your packets. At the moment, there are none. So right now, SDN is used by the provider to make their network more scalable, faster, more easily consumed by you, the user. And you, up in the application layer, have to use NFV if you want to have a secured deployment in the cloud. The state of the clouds right now is, even in these VLAN isolations, if you don't run some sort of encryption in your data in motion, all that data in motion is plain text on their network. Now, the cloud provider might be better than 99% of enterprises at creating that data center. Physical access control, the guns, the guards, the glass, the gas that's not halon, it's now like CO2 or whatever. They might be better than most enterprises, but still, there's a potential, there's an attack vector. Also, you as a business owner or whether you're on the IT, the dev, or the actual business side, you have to attest, and in regulated industry or not, that your stuff's safe. That if you're moving stuff to the cloud, you're controlling it. So how do you do that? You do that with network function virtualization. Here are some network functions: a router, a switch, a firewall, a VPN concentrator, a protocol redistributor, and some form of scriptable SDN. Use those things together in the application layer to exact that control in this third-party controlled environment. And what you end up having is you get control over your end-to-end encryption. You can then have all data in motion encrypted. You can have control, fine-grained control of your IP addressing. And I'm not talking about just intra-regional. I can have a VLAN with a 172.31.10.5 assigned to a server that I want it assigned to. This is true separation of location from identity, so that I can move that IP address around to different clouds, different regions, and federate those resources. The other thing you can do with NFV is a lot of times is called defense in depth. Like I was saying, the cloud provider offers up edge protection, isolation from other people inside the cloud. They have a really robust network firewall. Those are all things that are owned by them and controlled by them. And all the clouds out there do their security white papers, and they do a really good job. Whatever the new SAS 70 is, like SOSC or whatever, SOC 1 and 2, whatever the certifications are, the audits to say that they have the good access management. Their people can't bring in and out of hard drives. They destroy this once a customer deprovisions it, and they DGOS whatever, all that stuff. They do a really good job of that. But you have to have some kind of orthogonal lattice. So independent mechanisms that stack up to create this lattice of multiple layers of security in the cloud. If you're going to move stuff there, because that's what you do in colo, that's what you do in managed hosting. Why is the cloud any different? Why should you trust someone you don't know and you pay hourly more than someone who works for you, that you vetted, that kind of thing? So the next layer is provider owned, but they offer up some controls. And all clouds do this. This is called the hypervisor firewall rules. So if you're familiar with Amazon or HP, they call this security groups. In IBM SCE, this was done via a parameters XML file. Google Compute is just called networks, and you control it through the network. But this is telling you what, at the hypervisor level, am I going to let in to my instance, and what am I going to let out? And you can control that as a user. But then there are other layers that you need to then apply this security process to. And this is user-owned, user-controlled product plug. I won't get on it too much. Blue's us. You can do it via virtual network through unique cryptographic keys, and then there's another network firewall that you can control there. And then down at the actual instance layer, control your OS port filtering, and then even encrypt your disks for data at rest encryption. NFV allows you to, like I said, federate across multiple clouds, build hybrid clouds, and do it in a way that you've been doing it forever. Reuse all those skills, reuse all that expertise, use this industry standard IPsec tunneling, use the industry standard algorithms, hashing, and Diffie-Hellman groups for your tunnel negotiation. Nothing new, all the same stuff. So who are the players? And that's unfortunate. So this has turned out to be like that Verizon map. There's actually a world map in gray behind this that I don't think you can see. So over here you have North America. This is UK, mainland Europe, Brazil. That's the Arabian Peninsula, and then you have APAC over here. Probably Singapore is the highest density. Yeah. So here are your colo managed hosting locations. These guys like Equinix and stuff that build their data centers globally, and each dot represents a collection of data centers, more or less, for the bigger players. And what I'm trying to express here is there's a global distribution of these colo guys, and a lot of these guys will allow you to do kind of direct connect into any cloud provider. So this is kind of step one. If you want to pay on a more monthly to yearly contract, put some servers into some managed colo, this is a place to start. And then you can hook them into this, which is another one of these. This is public cloud locations. Similar setup. There's just more Australia in the public cloud. And all these dots, all these companies on both of these slides are kind of from a North American perspective. So there's kind of a dark zone in the, China Panda Cloud, India Curry Cloud, Russia Vodka Cloud area. That there are probably some regional providers that play in that space. But looking at this from U.S. point of view, how can I spread out through a U.S. company and subsidiaries of that? So good global distribution, and something that I wish I had some more time to do this and map it out kind of through time, how this stuff has come on in the last 8 years. That would be pretty telling of how and where we're growing, because guys are bringing up new regions all the time. So the point here is the cloud, its edge is getting ever closer to everything. And that's a big deal in networking. Network distance is a big deal. It's what costs money, and it's what impacts performance the most. So less public internet you have to travel over, the better. And the public clouds and the managed colo guys have built their networks so that they can communicate with each other really well. So as long as you get to their edge, you can hop onto that kind of high-speed public transport. So economics of distributed cloud computing today. Jim Gray was a Microsoft research fellow who unfortunately was lost at sea, but he wrote a lot of really great things before he met an untimely end. One of them was the distributed computing economics, and it came out in 2003. And the point of it was, he was saying you got to move your computers close to the end user so that you're doing less over network distance. And the whole point is, what does it cost to build WANs? Because we got to start building out these wide area networks so that we can control the speed of the interconnectivity between distributed groups of people, customers, data centers, whatever it is. In 2008, the EECS department at Berkeley did just a refresh. They just we're going to come up with some new numbers. What's the 2008 equivalent of 1 Mbps WAN link? They decided that it was 100 meg, and then they put some updated costing. And so they put some other numbers around cost, performance, and improvement. And the cool thing that they did is, what is $1, if we took $1, what could we rent? How much could we rent $1 worth of this these metrics. What does this cost us in Amazon in 2008? And you can see that you get some cost savings. I mean, this is pretty early on in Amazon, and actually this $2.56 number to get 128 CPU hours of a 2 gigahertz chip, they got their math wrong. I don't think that they were really looking at what an Amazon Elastic Compute Unit was, but whatever. It was getting close. Cloud was getting pretty close to what you could do in the physical world. Update it to 2013, it's pretty cost effective to use cloud. Cloud has an amazing cost driver here. And you can see the savings percentages. Now, I will say that I went and got this number for the compute for an M1XL, which is a 8-core device. I went and got the lowest spot price. So that's the lowest price you'd ever pay for that instance. It probably would be more. But I liked my 67% cost savings number there. So I was shooting for the marketing number, but comes with a caveat. So cost is there, but there are a lot of other drivers when you're going out and you're building connectivity. How am I going to do it? Am I going to do it physical, or am I going to do it using the cloud network backbone? Essentially, cloud as points of presence. Plenty of cloud fluff. Cloud washing is happening everywhere. The cloud's the greatest thing that is going to cost you a fortune and get you fired from your job, kind of thing. But the decision comes down to the following: whether you're going to build it out physically or whether you're going to do it in the cloud. Where are you in your hardware refresh cycle? If you just plop down X dollars for a 50,000 square foot data center, you're probably not going to use a lot of cloud, because you're going to try to bump up utilization in this big investment you just made. What's the project? Does it have budget? How much money do you have to put towards this? If you have a budget of hundreds of thousands of dollars, and this is a huge project, it might make sense to build it out in the physical world. So I'm not here advocating that Cloud WAN is don't build out physical WANs anymore. It's use case by use case basis. Definitely organizational expertise. If you think you have the skills and staff to select a bunch of vendors, put together and piecemeal together a bunch of leased lines, points of presence, and whatever, go for it. If you don't think that you have the network expertise to build it in the cloud, then maybe you need to call in IBM and do it in the physical world, or whoever the contractor is that you work with all the time. MBO's business side, if you're chasing some carrot, that's going to drive where you're going to be building out your WAN. Same, revenue targets, someone related. And then job function or role. If you're the IT guy who just, slogs away, day after day until, that once every 9-year hardware refresh cycle happens, and you start getting wined and dined, and you're going out to, baseball games, getting taken out to dinner, and it's going to be tough to tell that person that all of a sudden we're going to go to cloud, no more of that. And instead of, on top of all your regular stuff, you got 40 more things to do today, because we're ready now and we're rolling out today. So job function role, big impact. We find that when it comes from the business side, it has a higher chance of getting to the cloud than if it comes from the IT side. So what does it take to build out a traditional versus a cloud WAN? Traditional WAN, you got to get points of presence. This is all about extending the network edge as close to those people or whatever you're connecting to. So that's building data centers. And that could mean building data centers, shop for real estate, become an expert in facilities, hot, cold, whatever, raised floor, whatever the latest and greatest is. I've fallen out of touch with the data center movement. So hopefully that is fairly representative. Hire a team of security guards. So get the guys with the guns to stand at the doors. Or you sign deals with telco carriers. And this can be anything from piecemealing a bunch of Bill and Ted's Excellent, whatever, in a bunch of places that you need to reach. Or a lot of times, if you're extending a WAN to like a global WAN, you're going to be working with some pretty big international telco guys that have presence in all those places, and that becomes a pretty expensive proposition. And if you want more, you got to start over, and that's Google getting cheeky with their data center. Anybody see that when they let the street view run through their data center? They put a bunch of random crap in there like stormtroopers. Again, my map's gone, but you guys have seen this chickenpox map without any visual reference, so sorry about that. Points of presence with cloud. It's leverage all those dots that we saw everywhere. Generally, if you're operating in US, EMEA, APAC, you're good. If you're operating in Africa, you might have to call up Bill and Ted's and start hobble-cropping a bunch of stuff together. And what it is sign up for points of presence in the cloud is you need a credit card and go sign up and create accounts. A couple minutes. Want more pops, sign up for another cloud or activate another region. You got network kit. I had this called network compute, but some people said that might be misleading. But network devices are computers with OS that are just specially tuned hardware, specially tuned OS to do networking. So it's computers. You're buying computers to run your networks. You're going to have to go to Cisco and buy a refrigerator and find someone to hook it up, and hopefully they label all the wires and make it neat, because my OCD would go insane. Or you sign a bunch of deals with telco, large international telco, expensive. Network capacity in the cloud. That's the great thing about cloud. Everyone represents their cloud as infinite resources. So everyone says it's scalable. We're never going to run out. Some of the smaller guys, if you hit certain areas, they might start slowing down. But by and large, the well-capitalized guys, like the guys up here, you're going to be hard pressed to take them out of business. And then finally, once you have those points of presence, once you have that kind of network kit there, that network compute capacity, you got to link them all together. And this is really what it's all about, is the leased lines. I don't know if anybody's ever had to deal with like the Cogents or the Verizons or the Savises or the AT&Ts back in the day. It's insane. One of the first projects I did, this is a quick anecdote, out of college, was working at a software trading platform. We're a software company that did trading software for the US derivatives market. Yeah, tripped right over that. We had a bunch of leased lines to a bunch of our customers and also to price feeds. And I came in and had like a 350 line spreadsheet of all our leased lines. And it was like, all right, go through that, and we'll let you keep your job if you save us 25%. It was a nightmare. So you could do that. You can go and shop for telco carriers, vendors, have them draw leased lines from wherever your data center here is in Omaha, and I need a lease line over to Philadelphia, and stitch up your mesh that way. Long-term lock-in is expensive, and you're going to be paying based on network distance and network performance. So as the distance increases and the performance needs increase, the price goes up. In the cloud, they've done all this for you. They build out their region structure. They pull essentially direct connect lines between their regions. You go out through public internet over intra-region, but it's a lot faster connection than if you were going to like Amazon US West to Amazon US East is way faster than if you're going Amazon US West to some other cloud in Northern Virginia. That new termination point might just be a block south, but it's not running over Amazon's leased lines between its data centers. So they've stitched this mesh together for you, and this is already included in the price. And because they're, the economy of scale, it's already super discounted, and you use your fractional whatever you want without the long term. Pay by the hour, pay by the gigabyte. So I want to get now into maybe some specific use cases, how people are using this now. And what I really want to highlight here is some of them are in regulated industries, some of them are not. One of them is in, like I said, in Africa, and did this in Africa where there really isn't any cloud structure there, but has been kind of piggybacking off of some of the EMEA clouds and then drop down in Africa and come back out. So there's a lot of options. This one is a customer provides mobile banking software to a number of banks and credit unions. So not the Chases, not the tier ones, but maybe some of the smaller like family credit unions and smaller banks, local banks that want to offer up those mobile payment options, those online banking tools, but don't want to build it in-house, so they hire a third party. And the way that this third party delivers is kind of hybrid software delivery model. Traditional software delivery where they ask for a couple U's in a rack inside the customer's data center, but then also they built out a bunch of it in the cloud. So what they needed to do is they needed to build a WAN between each server in the customer's data center and their cloud WAN and some of the servers back in their kind of home network, home data center. So they tried doing this at first, just hosting everything in US West, and guys on the East Coast had really long latency, performance issues. Their customers were complaining, the spinning beach ball kind of syndrome. So then they started spreading out their compute across the cloud. And 350 customers that they have, they decided, well, we need to go in this region, this region, this region, this region, this region. And it happens to be across a couple different clouds. And they've just extended that edge closer to their customers so they can deliver their solutions more quickly and easily. This is a security firm. So one of the bigger identity access, identity management companies out there. Similar deal. They needed global points of presence. They needed to get right up to the edge of their customers so that they could hook in and they could get the solutions quickly and easily. And the key here is, Cloud WAN, great, but coming from a security company, this was where they really put together that lattice themselves and really created this extremely robust cloud deployment that I would say is more secure than 99.9% of the enterprise data centers out there. They have complete control over it. They have, all the kind of network function plugins, so intrusion, all this stuff, intrusion, extrusion detection, really robust deployment. Because that's the business they're in, and they have SLAs, and their customers come to expect a certain level of service. Pharmaceutical company does this, and this has some HIPAA implications because this is, again, regulated industry connecting down to medical offices, hospitals, and back into their own data centers to spread this pharmaceutical system network across all these sites, owned and not owned by this company. And this one's really cool. This is a group of guys. I don't know if anybody's had a lot of experience in Africa. SMS is a big thing down there. Most cell communication is done SMS. Most advertisement, because it's difficult to reach a broad base of people between countries, there's a lot of advertisements pushed via SMS. And these guys offer, essentially, they're an SMS bridge. Because you have each individual country, there's a communications commission in Nigeria, there's a communications commission in Ghana, there's a communications commission in Uganda, and so on. And they regulate their industry. And as a result, the telcos end up siloing off a little bit. And so intercommunication between, say, Visafone and Airtel over an SMS network used to not be possible until this guy came along and offers up the SMS bridge, both for users so that I on Airtel Ghana can text my buddy on Visafone over in Nigeria. Seems something that we might take for granted, but something that they didn't have before, excuse me. And then the other thing is SMS advertisers can now plug into this and shoot their advertisements out over multiple telcos, only targeting one endpoint. So really cool, use the cloud. And the public clouds they're using one of the Dimension data clouds down in South Africa, but then they're shooting everything back up to the EU just because there isn't much compute capacity down there in Africa at the moment. So an opportunity if anybody's looking to go out, raise a bunch of capital, and build out some data centers. And then the last thing I wanted to talk about is what I think the real value is to the cloud network backbone, ready for us to consume, I'm going to make a telco. I'm going to be a telco, except it's going to cost me next to nothing, and I'm going to control the network. I decide who comes and who plays, and I build out this global distribution at my monthly cost. I have this running in my personal Amazon account. Costs me something like $97 a month. If you were to build that out today, I think you'd be over $1 million pretty quickly. Just if you wanted that space and actually the compute that I'm running, over $1 million in data transfer. And what this allows me to do, and I'm just running a SIP server in the cloud. So I don't know if anybody's in here is familiar with SIP. It's just it's a communications protocol. Anyway, and I connect in using an SSL tunnel on every phone, because you can load OpenVPN onto these guys. And I connect in, and what it gives me is I get double encryption on my phone calls. I sign my own certs. You can't triangulate who I'm calling, because I'm calling private IP addresses and private usernames. So I'm never referencing another public IP or public phone number from this. So what does that mean? It's a pretty cool demo. And of course, I'm not going to put anything related to NSA Prism in type ever, because I don't want to become a target. But I'm now Tin Can Telco. Big Brother and telemarketers aren't welcome. So I'm not going to let telemarketers come on, and good luck NSA trying to crack my keys. When I think you have, I'll rotate. Because as we know, all of the signing authorities have been cracked for years. Sign your own certs. If you're just going to take away anything from this talk, be your own signing authority. So that's all. Our blog, I gotta push this out there. We do very little promotion of our products on our blog. We try to actually put real content out there. Take a look if you're so inclined. And then Cloud Camp. This is a unconference thing that we started with some guys, Ruve Cohen, Dave Nielsen, and a couple other guys. We started the Cloud Camp series. We run the one in Chicago and London. There have been a couple in Austin. I think I've seen. The last one was in March, but check it out. It's free pizza and beer. Come talk about cloud use cases, no product pitches, that kind of stuff. So it's a good community, so check that out. And that's all I got. 40 after? Good enough. WAN stuff really in the last couple years. So as my networking knowledge got to the point where I could start understanding how I wanted to think about things, that's when I started playing around. And that was really driven by the maturity of our product and what we were seeing in the marketplace. So not from the beginning, but as more clouds have popped in, right? Because everyone's becoming a cloud. MSPs are becoming CSPs. So as that keeps building up, then there's just more opportunity to play and cooler stuff to do.
So just out of curiosity, what is your actual product focused on? Is it like cross-cloud overlay networks?
Yeah, exactly right. So it's this. I mean, we do the hybrid device. It's all those things.
You guys deliver it as like an AMI?
Yeah, it's a virtual appliance. AMI, I mean, any virtual format, right? So all major clouds targeted. It's in the partner directory, image directory of most, AWS Marketplace, all that kind of stuff.
Operating system based on?
Of course, it's a specially tuned network. It's based off of Ubuntu 12.04.
Working primarily on layer 3?
Yeah, I mean, if my CTO was here, he'd be like, well, it's 2.5, but I don't know. Me as marketing director, I'd give him a thumbs up, but 3.
So your tin can personal network that your phone's encrypted with, is there a recipe book that somebody else can follow, or is that proprietary?
That's proprietary at the moment, because I'm trying to, full disclosure. Hopefully no government employees are sitting in the room. I'm trying to get the NSA to take me out, but once that fails, we'll start getting it out there.
How does it work on your phone when you VPN'd into that
Yeah. So what I am is I'm VPN'd into the overlay network, and then I'm actually accessing the SIP server using. There's a company out there called ID Rank Security. They have something called MyCryptophone, which does another layer of encryption, and it's always rotating encryption every minute. And it's a layer on top of the SIP. So I'm using my SSL to get into the network, and then I'm using my cryptophone on that private LAN.
And what app do you use to make phone calls?
My cryptophone.
Oh,
Yeah.
Okay.
So it's from ID Rank Security. They're grouped down in Tampa,
Okay.
smaller group. Any other questions? That works for me. Thanks. Really appreciate it.